freaking me out. Makes me feel all trapped inside. Quick, somebody tell me what that's a reference from a movie. Makes me feel all trapped inside. What movie is that from? In fact, I think I'm going to start doing that on every live feed now. I'm going to try some esoteric and some not so esoteric movie quotes. So we'll have one every, because, cheers. Well, we're going to have one from now on. So makes me feel all trapped inside. Somebody tell me, somebody let me know what movie that is from. And so people, I'll repeat that again later. Oh man, it looks like I hacked myself here. Probably we put our tree up. Maybe it was that. Got our Christmas tree, Christmas spirit. Everybody's in. What we're going to do tonight is we're going to talk about top secret power things that I did when I was competing in the Engine Masters Challenge. So I'm not an engine builder. I'm not John Causey or Bischoff or any of those guys. But the benefit that I have that a lot of people don't have is that I have like an endless amount of dyno testing. So and when I do things, I don't just run something on the dyno. A lot of times engine builders will, because they're selling engines or whatever, they'll build an engine, they'll run it, and they'll come over and run it on the dyno. That's not what I do. What I do is run it on the dyno and then change 50 or 60 things and then find out, does this cam work? And then does this cam work with this intake manifold? And does this thing work with this thing? What happens when we add boost? What happens when we add nitrous? All of that stuff. So, and I took the same approach because when we were, Engine Masters back then, the year that I did it, it was 410 inches. What they did was take average power and average torque, combine them together and divide it by 2, and then you get some sort of average number. And so it's very important over a given RPM range to have average power production. So it's a lot easier if you just focus on, okay, who makes the most peak power? That's good. Not oftentimes useful, but good still, or even if you did something like, okay, I'm just going to go for average or peak torque. That's good, but not really usable. So I think that the idea behind this Engine Masters Challenge was, let's build engines that are in the useful RPM range, which is good, like 2,500 to 7,000 or whatever the range was. And that's still useful, like streetable kind of range. It's not a race motor. What? It's not a stock motor. It's it's a good combination of street strip kind of thing. These weren't that. These were more as they got more and more serious. They're just motors that do specifically what this challenge was asking them to do, and they did it very well. But having the average power production thing made things harder because we know how to. It's a lot easier, like I said, to get one of those things, but to get the combination of all of them, because more often than not, I think I had 400 or 500 pulls during testing, and shout out to Tom who worked at WestTech for helping with all that stuff. So that was awesome for a guy to do that. So Tom, thank you very much. If I haven't said it before, I'm saying it now. I've said it before, but I'm saying it again because he's done so many great things, and he's a fantastic guy, a heck of a fabricator and stuff. And he's just an all around good guy. But we did a bunch of testing on that motor and ran endless number. And it's more time consuming to do that because when you're doing that testing, you have to be very, very particular. It's not like a lot of times we just run stuff and go, let's do it, but when we're doing Engine Masters, you have to be very particular. The oil temperature has to be this, the water temperature has to be this, the air fuel has to be this, timing has to be, all of those things where you have to be a lot more stringent on that because in competition, they're going to be stringent on it. And so that's very, very important. So we're looking for an average number. And when you do something and you go, hey, look, I gained whatever this average number was, it has to be repeatable. It has to do that every time. So you have to make sure you have to redo the, wait for the oil temperature to get back down, get the water temperature at the right thing, and do all the testing. So it just takes longer to do all that. It takes a lot longer than it does just to run an engine 400 or 500 times. That's not that hard. But one of the things when you're doing all this is that, like I said, I'm not a professional engine builder. I've built a lot of them and tested a lot of them and tested a lot of different combinations, even within one kind of motor. We've tested a lot of stuff. So I tested, if you take a motor, you test 8 cams on it, you're like, I have a pretty good range now of where things are going to be with this kind of motor running from a 208 cam to a 238 cam, let's say. I'm like, okay, we have a fairly good, grasp on what's going to happen. But in Engine Masters, when we were looking for specific things, or when we were trying specific things and we're looking to get this average power production, more times than not, we would see a gain, because you get so that if you've been dyno testing a long time, you look at it, you load the thing, release it, let it go during the run. You're watching the thing. You're like, oh, I saw 681 horsepower. So that's higher than I've ever seen yet, because before we were at 678 or something. You're like, okay, it made power. It did. It made more peak power. But it also lost an equal or more amount of torque down low. So your net average of all of those could be nothing, or it could even be a loss. Now it could be a +1. You could have gained 1 point, and meaning not 1 horsepower or 1 foot-pound of torque, just one of those. And so you did see a gain, or maybe not. And then if it's 1, does it repeat again when you do it? And so, like I said, more often than not, what we do is we'd pick up somewhere and lose somewhere else. And so the average number would stay the same or go down. More often it would stay the same or go down rather than go up. So we had to try a lot of things. Like I said, that's why I had 400 or 500 dyno poles in it. And if you take a look at the thumbnail that I have up, one of the things that we tried, mine was a little bit unique. Most people, because we were running, I think, the 7,000 RPM, most people at that displacement limit, 410 inches, whatever you pick, a Ford, a Chevy, Dodge, whatever, they tended to steer, because we weren't doing LS motors, we were just doing, small block stuff. Most people tended to gravitate toward a single plane intake manifold, and rightly so. The winners won with that, so they obviously made the right choice. I did a dual plane intake manifold. I did a heavily ported dual plane. I did a 410 inch small block Chevy, a Windsor base motor, but then I did an RPM air gap that we EXTRUDE-HONE ported twice. So I did it once and picked up a bunch of numbers everywhere. I'm like, this is fantastic. Let's see now if we can get more. And we did it again and had them take out even more, because one of the things with that manifold is that was designed for a 351 Windsor. So it was undersized for the power level that we were at, which was, I'll just say, between 600 and 700 horsepower. So it was not sized for a 408 to begin with, and not sized for a 408 that was making the kind of peak power and peak torque and stuff that we were making. And so we ported it and then ported it again. And we did pick up more numbers, not as much as we did the first time, but we did pick up more. And then one of the things, if you look at the thumbnail, one of the things that we tried is I ran a 750 or an 850 Dominator carburetor on this. And looking back, I'm thinking I might have went with something. I should have went with something bigger than that, because I'm thinking now that probably was not enough. It did very well, but I'm thinking now that I say that out loud, and somebody was asking me, do you ever? I think the guys from the Street Alpha podcast, he said, do you ever go back and did you do something wrong? I'm like, yeah, that happens all the time. I go back and question myself in these tests and these dyno results. And then in my explanation for the dyno results, I question that stuff all the time. I go back and look at my results and go, I don't think that you got that right. I think we need to reevaluate that. And I think this is one of those situations. I think the carburetor that I used, even though it was a Dominator, it was a 750 Dominator, probably flows more than the 750 4150, but I don't think it was big enough. The thing that I liked about it is it made more power than when we had a comparable 4150. I didn't ever run a 750 on it. We ran a 950 4150 on it, and it made more power with this Dominator on it. But now it makes me think that I never tried a bigger Dominator on it. But what we did, I'm going off on a tangent. What we did was we ran the ported RPM air gap, and then we ran an adapter, a 4150 to a 4500, and then put this Dominator on there. And then we tried doing all sorts of things. So we ran it just as an open adapter, basically. It would be the equivalent of, you know, this would be at least a 1 inch, and it probably was more than that. The tapering out to the 4500 probably was an open spacer essentially. And in this case, that motor, that intake manifold certainly needed that. And in fact, I did a post today on single plane versus dual plane. And the thing that's in between that is a dual plane with an open spacer. It's doesn't make an intake, or doesn't make a single plane, nor does it completely take away as a dual plane, but it adds power on the top and sacrifices a little bit down low, but putting it kind of in a midway position between those two. And that's exactly what we tried. We tried this adapter to the 4500. First, we tried it open. And then, as you can see in the thumbnail, we made a divider. We continued the divider up from the divided manifold that this RPM air gap was. And then we cut our little RPM air gap slot in there and tried different versions of that. And one of the things that we found is we had to make that thing like structurally sound, because the first time we tried it, it was like, you know, it had a vibration. So it had a high pitched noise. It was going woo, because that thing was vibrating so fast. It was really cool. Other things that we tried, we did that. We tried different gaskets, different thickness gaskets. We stacked gaskets between the top of that adapter and the carburetor. We tried some under the adapter because, you know, like I said, I'm not a professional engine builder, but I had the dyno, and I'm not above trying things. So I've long ago pushed aside this notion that I know more than the dyno does. I don't. So I know that the more questions that I ask it, the more answers that I'll get. And in this case, we got a lot of answers, like I said, and most of them were, yeah, you did great here, but you didn't do as good here. And so the net thing was not good. That setup actually worked fairly well, and we were able to pick up pretty good power. In fact, we were right there in the hunt when we were done with that combination with what eventually would be the winning average power production. As you guys know, who have watched this before, they kind of overheated my motor for me during the warm-up session, because they weren't running the water pump. And so the thing just, every pull that they made, it just made less and less power. So it kind of hurt it, which was kind of a bummer. I would have liked to have seen, I mean, we ended up in the top 6, so we were in the finals, so it was good. But then after that, it just, like, when we started doing the finals testing, you know, it just went downhill from there. But I'm not bitter. But the upshot of all this stuff is that, like, on that thing, that's probably not something that most people would look at and go, this is what's going to get me the number that I want. But you don't know. You got to try it, because if you don't try it, then like I said, you don't know. If you try it and go, hey, look, that didn't work, then you go, well, I was right. I was right all along. It's not going to work. And it didn't work. So now when somebody says, will this work? You could say no, and not just have that be an opinion. Now you have no, and here's my data. Here's the thing that I have that corroborates that, like, basic belief that this is terrible and it didn't work, or at least it didn't work, you know, and that's part of the problem with all this testing, is people will say, well, what happened when you did this? I'm like, well, it didn't, like doing, one of the common questions is, did you do rockers? Like, did you do, because it's a small block 4, did you do 1.7s on the intake and 1.6s on the exhaust, or did you try swapping those, or did you only do it on the 1.7s on the long runners and not on the short run? You know, all these different combinations. I'm like, look, we tried all that stuff, and yes, it worked, but it didn't work to help us out in what we were trying to achieve. It might help you out in what you're trying to achieve, but if you change anything other than the combination that we had, the specific camshaft that we had, the AFR heads that we had, you know, the specific things that we had, if you don't have that, your results might vary. Let's see what you guys got going on. So we're gonna have a polio. Did you watch the Okay, did you watch the Street Alpha podcast interview up on YouTube of me? He has a lot of good ones. I think my favorite one might be Shane, but if you guys watch that, you should. It's good. Cheers. Frosty beverage. Lisa has figured out a new beverage concoction, and it's awesome. Cheers. Greetings. Richard, love your interview with the Street Alpha. Okay, so you did see it, obviously, so your answer is going to be yes. If you didn't see it, then you should go watch that. I did a razor blade rebuild today on a Gen 3 5.3. Nice. Those deserve that. The previous owner must not have believed in oil changes. It's really amazing how much neglect these can have. They can. When you take them apart, and the first thing you're going to see is a difference right to left on what the rockers look like because of the way they run the PCV system. PCV, PVC pipe. You'll see that difference, but then you'll also see, like, depending on whether or not they did, what kind of oil they used, but whether or not they even bothered to change it. You'll see lots of buildup and stuff, and it's. I've seen some like that 4.8 that I had that I shouldn't have got and had all kinds of problems, and it just was horrid. I mean, it was terrible inside. Did you grab anything Bailey Brothers closing? I have not. What is that? Have you reported pistons? Have I ever dimpled them? What are the RPM limitations to a TKO 4500 or to a TKO 600? I don't know. Would there be an RPM limitation on the transmission? I feel like setting valve lash is harder than it needs to be. Lots of different ways people do it. How do you do it for hydraulic lifter? We do a half a turn past zero lash on a hydraulic. It's really simple. I mean, the way that I was originally taught way back by my stepdad is that you would the motor would be running, and you'd back the rocker off to where it started clacking, and you tighten it down until it stopped clacking, and then you'd go a half more turn. And that's a half turn of preload, basically. The problem with doing that is that it's, especially if you just put together a fresh motor like we did, it's just squirting oil over the valve or over the fender wells. I mean, it's terrible. So that's why they made those little clips that you put on, the oil deflector clips that you put on the rockers. And so it has a little cover over the oil squirter that comes out of the push rod into the rocker arm that's supposed to dribble oil down through there. And it doesn't always do that. Now, ours had a lot of oil pressure and would squirt it at you. So it's not good. They were a speed shop in American Canyon. I'm not familiar with them. Do you think the Alice 4200 deserves more support? I don't know what you mean. It's not a very big. Did they even use a lot of those? I mean, I love the stuff that Calvin's doing, and it's a 4-valve motor, and it works well. I think some of the problems with it is it's very, very tall from oil pan to the top of the valve cover to the top of the intake manifold. But I like them. They make good power. Watched about 80% of the interview. Nice. May have covered this, but Brian Tooley sold to private equity. Yeah, we talked about that all last night. Last gauge setting, gauge, feeler gauge. Nobody I know uses a feeler gauge for setting hydraulic stuff. Hydraulic stuff, whether a hydraulic roller or hydraulic flat tap it, you would just go half a turn past zero lash. On some of the stuff that has a bolt down rocker, you have to count, like with the LS, you have to count the number of turns that you get past zero lash. And that's going to determine, because you have to adjust it with push rod length. A lot of these you don't adjust because it has like an adjustable rocker on it. And so you determine that. Now, the adjustability, like the importance of the push rod length is still important because you have to get the right rocker geometry. But when it comes to setting it, it's going to be the same regardless of what the rocker geometry is. It's still going to be clackety, clackety, clackety down to where there's no clackety, clackety, and then you go a half a turn. And you can do that. You don't even have the motor running anymore. What we do is, like on a small block Chevy, you would tighten it down. You could feel that there's clackety, clackety in the rocker that it's loose, and you tighten it down until that's not there anymore. until it's just in, everything is in contact. The lifter's in contact with the cam, push rod's in contact with the lifter, the push rod's in contact with the rocker, and then the rocker's in contact with the valve tip. As soon as all of that has just happened, then you go a half a turn. And honestly, like on a small block Chevy or whatever, small block Ford, once you've done that, it doesn't matter that one of them has a half and one of them has an eighth past the half or an eighth less than a half or whatever. None of that matters. It won't affect power at all. Tighten until it touch clackety clacky. That's right. Do you have valve covers with holes cut in them for adjusting valve lash? Keep the oil out of your face. You can also do that. But even way back in the day, even when I was doing this, I mean, this was on a 1970.5 Rally Sport Camaro. But even back then, they had the little clips that was like a prong and a centerpiece, and you just slide them on the rockers, and it just the little centerpiece just covers that oil squirter. I've been told to go 1 turn all the way to 2 turns past 0 lash. No, not in any hydraulic do you want that many turns. I want to redo mine the right way. I wish you could use a feeler gauge. Yeah, you don't want to use a feeler gauge. That's not going to be the right way. And a valve cover with a rectangular hole cut on the top to deflect the oil. Yeah, you can do that also. You can make it so that the valve cover overhangs the squirty part. It's technical. And so that the oil doesn't hit you if it does squirt out. Sometimes it doesn't. Sometimes it just dribbles out onto the thing. But usually at any kind of RPM, it's squirting pretty good. But yeah, no clackety clack and then half a turn. Long Island iced teas. No, it's not. But Lisa has had Long Island iced teas before. In fact, that's the only thing that made her go snorkeling with me when on one of our trips.
Are you talking about my Long Island?
Yes. See, that's Lisa. Are you talking about my Long Island iced tea? Halfway through the Street Alpha podcast. So cool. Yeah, it was very cool. It was definitely, going from California to Florida, that's a long trip, but definitely worth it. The Toque is very cool. And JDM Dre, I think, is the guy that let us use his place. He's got a lot of fantastic Supras there and stuff, and a NSX and just all kinds of stuff. You want the push rods to spin. You're spinning the push rods to find out when you have 0 lash, and you have 0 lash when the push rod doesn't spin anymore. When did you film the Street Alpha podcast? It's been a couple of months now, I think. It definitely wasn't during the winter. I'd have to look back and see when the trip was. But I think it's been a couple of months. Yeah, I thought he was going to get it up before, because this was before, it was before SEMA. At 0 lash, push rod stops spinning. Yeah. Yeah, that's how you tell. If it's spinny, then that's not 0 lash yet. No spinny, no winnie. I keep getting a thing about night vision. I don't know what they think that I'm doing. I do like watching those videos though. I like watching the thermal and the night vision stuff, and then how they go about getting around that. Pretty cool. It misfires if you went too far. Yeah, on the LS stuff, if your push rod length is too long and you have, like, let's say 2 turns of preload, they can hold the valves open. And then what happens is it either won't start, or it's very rare that it would happen just on one side, not the other, because usually they're the same. Usually you mill the heads the same amount, or whatever change you're making, it's constant between both sides. But if it was one side, it could run on 4 cylinders. We've had motors run on 4 cylinders all the time. We started motors up with like the coil pack unplugged. It still runs on 4 cylinders. It still rev up and do all that stuff. But most of the time it just won't even start. In the Engine Master Challenge, it's against the rules to use dual runner manifolds like the Gen 3 Hemis have. It seems like this design would dominate with both short and long runners. When I did it was long before you had dual runner manifolds. So I don't know if that's a thing. That would definitely help. Got the Street Alpha save for later. There you go. Use adjustable push rods. I don't. I use adjustable push rods when we're first measuring for push rod length, but I do that in a stationary thing. I don't. On the adjustable push rods, you don't want to normally subject an adjustable push rod to valve spring pressure, so you don't want to rotate the thing around and see if it's working. But yeah, when we're doing setup, or when we're doing setup with a where we would rotate the motor and we would check for like what the contact pattern is on adjustable setup, you could do that with an adjustable push rod length, but you do that with a light checker spring. Which camshaft would be better for an L92 truck plus or low buck truck? I want the simplest cam swap, no converter, mild manner, just slightly more power everywhere. It's an L62 with a 6L80. A low buck truck probably would be a better choice. I think either one of them, well, we know that either one of them will run with a stock converter. We run a truck plus right now with a turbo with a stock converter on a 5.3. So your L92 will definitely run with a with that camshaft, with either one of those camshafts and a stock converter. You're just going to have a good tuner. How'd you get into the dyno and flow bench side of the industry? I have done a lot of flow bench stuff, but only because it was there at WestTech. But the dyno stuff happened as a outgrowth of me writing stuff for the magazines. And then one of the magazine guys helped start WestTech and then said, hey, you need to come out here because you're that kind of guy. And I did. And they hadn't been able to get rid of me since. I wore them out enough where they just said, look, here's a key and here's the alarm code, and just please just lock up whenever you leave. A 543 valve junkyard turbo video would be great. Yes. I agree. I've run turbo 463 valves, so we know what they do. Spoiler alert, they do what every turbo naturally aspirated motor does. They do it as a percentage of how much ever boost you run. A 5.4 would be the same thing. Learned the hard way that a small block Chevy and 60-degree V6 have different thread pitches on the rocker studs. So did you try to put small block Chevy rocker studs in a 60-degree V6? Did you hold them up to see if the threads lined up before you tried? I hope you didn't try to impact it in there. Has an engine utilized VTEC for dual cam patterns or texted 4.6 intake style for dual runner lengths? Honda did that a long time ago. Honda did VTEC. They're the ones that designed it. And then on their GSR, they also had a dual runner intake manifold. And then I don't know if they've done any dual runner intake manifolds lately, but they have combined VTEC, which is 2 distinct cam patterns. And in some cases, they have 3. And then also variable cam, which they have 2 distinct cam profiles, but they also have advancing and retarding the cam. I think probably is just retard, but I want to have turn past 0 lash on the V6 and rattled like a diesel. I don't, then maybe you weren't at 0 is the only thing that I could think. Because if once you have 0 lash and then you put preload in it, it won't rattle. It can't. There's no way that it can. You have preload on the lifter. Is there anything else you'd upgrade or replace while doing a cam swap if you're building a street engine? So I do the trunnion upgrade at the same time. We on junkyard motors, I don't do that. I don't do trunnion upgrades because I'm cheap. So what I do is if you're doing a cam, you're almost always putting springs in it. So you got to do a cam and springs. That's pretty normal. If the cam that you add, like our low buck truck camshaft or truck plus camshaft, adds 60 horsepower or 70 plus horsepower, and you have stock injectors in it, you need more. You're gonna have to tune it, but before you tune it, you're gonna also need more fuel flow. So you're gonna have to have bigger injectors, because the stock injectors sometimes, depending on what size they are, they won't flow enough. On some of the bigger stuff, if yours is the 6.2 that we're talking about, it might be that those are big enough because that was a fairly high horsepower motor anyway. Some of those, like a LS2 or LS3, I think were 42s or 46s or something. And that's enough to support a lot of power. Some of the truck stuff are 25s, and that's enough for 400 horsepower. And you're going to be making way more than that. So a lot of times injector upgrades are necessary. Not going to lie, I would pay to hear our podcast stories that didn't make the magazine or videos from you and Steve. We have a lot of good stuff. Steve. In fact, I'm going to get together with Steve. I'm going to go out to, I think he's got a place out in New Mexico or somewhere, and we're going to do a podcast or something together. It'll be fun. And there probably will be drinks involved, which will be awesome because, let's face it. Happy hour in horsepower. I'm excited to use your G35 cam. Nice. I like it. And LS1. I can't find any reviews for you about your turbo like the G42 and GTX35. Can you explain the benefits of the G35 1050? Yes. Well, the biggest thing is you see that there's a difference in the power ratings for those. So we know we've made 800 with a GTX 3584 RS on a 5.3. Just a cam 5.3 and that turbo and intercooler, and away we go. The G35 is a better turbo. It's a ball bearing turbo for one thing, but also has it's a newer generation turbo. It's rated about 100 horsepower more than the 3584 is, and then about 200 less than the G42 is. So it's what I would call it's in between those two. Yeah, 200. So it's 200, 800, 1,000, and then 1,200. And so that's going to be a good turbo on your 5.7. I don't know how much power you're trying to make. Honestly, anymore, after, and I didn't know this, like we had run the G42 on a 5.3 on the engine dyno, and it did very, very well. But an engine dyno doesn't tell me what they do, in the real world. It doesn't tell me what they do when you put it in like Jimmy's Tahoe. And Jimmy's Tahoe is heavy, so there'll be more load on it. So the response rate probably would be better on that than it would be on a lightweight Camaro or Mustang or something that an LS would be in. So, and then we know that a turbo has different response rates in different gears because the load has changed. But after driving around in Jimmy's Tahoe with the G42 turbo and a 5.3 and even just a stock one, I'm like, I would not hesitate to have this turbo in a 5.3. I would have it in a heartbeat. I said, I had no idea that I thought it was going to be like super laggy, but it's not. And so in a 5.7 or a 6.0, I think I would almost get that turbo because then you can also have, like 4-digit power. But if you don't want that, then you want something like I was talking about on the Street Alpha podcast is like some guys want when they put their foot in, they want the boost gauge to go all the way to 10 pounds or whatever boost they have. And so that's also cool. Bought your LS cam and lifters for a 6-liter, looking for a rebuild. Need to do main and rod bearings. Looking forward to more stuff. Yeah, there's a lot of good rod bearings and stuff and main bearings out there. I don't think you're going to go wrong with that. As long as the clearances are right, that will be fine. And then you'll be happy with a 6-liter with a cam in it. What combo of motor heads and cams surprised you the most, good or bad? I don't remember doing a heads cam and intake manifold. I mean, we did a bunch of testing, like the 5.3, and this took a few shots to get to, but the 5.3 with the trick flow heads. Now, mind you, these are trick flow ASCAS 220s that have then been ported by Total Engine Airflow, or been ported by Brian Tooley Racing, who owned Total Engine Airflow. And then the Brian Tooley Racing Trinity intake manifold, and then the Brian Tooley Racing Stage 4 LS3 cam. Now, obviously, other cams could have done this too, but that thing made 540. So that's a lot of peak power. But again, honestly, when I did the poll, most people would pick less power to make more average power than that short runner manifold would make. But that was a really good one. Is thinner oil killing modern engines? No. Randall, I don't understand your question. Correction, low buck truck cam, L7 lifters, those are good. Be more concerned about extended oil change intervals. Yeah, I think that the fact that people tend to look at these things not as engines anymore, that they, there are a lot of people that may have never lifted the hood on their motors for a year or more. You think about that. I mean, not back in my day, but back when people were driving carbureted small block Chevys and going places in station wagons and stuff, going to a service station, you lifted the hood, you checked the oil, you checked the belts, you checked the tires, you did all that stuff. Or a guy at a service station did that. For somebody to just go out and get in their car and think that every day it should start, I remember seeing the first time I saw this, I was amazed. I'm like, that can't be real. That they said that the plug interval change was 100,000 miles. Like, how does the spark plug last 100,000 miles? I mean, back in the small block Chevy days, the motor didn't last that long. For spark plugs to last that long, that's what I mean. I don't worry about the oil stuff. Just change the oil. No such thing as 10,000 mile oil. There is. I know because my dad, who taught me about engines, I know he drove his 4.3 liter V6 Astrovan, and he easily went 10,000 miles without changing the oil. I'm like, you know about engines. How can you do that? We're just, he was surveying and stuff, and he's like, I'm like, yeah, but that's the van that gets you and your survey crew to work and out to the places. It's got to be reliable. I said, changing the oil is driving it in. You're not even doing it yourself. Just go do a Jiffy Lube or whatever. But, let Mrs. Holder, you need a refill. Joe Boo needs a refill. It's a good turbo size for VORTECH 350. Looking to make 600 wheel maximum. I don't really understand how to read the graphs. Go get from richardholdnerperformance.com. Go get the GTX 3584 RS for 350. It's going to be super responsive, and it will easily do 600 wheel horsepower. How much horsepower do you think I might be leaving on the table without tuning my TPI? I got 180cc heads, cam, 1.6 rockers, slight intake, manifold upgrading headers. I don't know how it's even going to run with a cam on a tune port motor and a stock tune in it. Does it even run? You ever thought about doing an SRT4 swap in the Omni, or is that a hush puppy shoe wearing crumb cake? No, but I'll tell you the swap that I have been thinking about, and I'm sure Ben and Brian are going to try to talk me out of it. But I want to put a Honda. I have a Honda K24 turbo and a 6-speed trans. That's what I want to put in the Omni. And it would be like, it's kind of like an SRT4 swap in an Omni, except way better in every single way. Better trademark than Happy Hour horsepower is a killer name. I know Happy Hour and horsepower is good. And everybody loved when we were down at our local watering hole and Lisa was there because, it's Lisa. Does the 543 valve have a similar power limit to the stock block 463 valve? I don't know that we would even need to worry about getting to the limit of the block. I can tell you that a 543 valve and a 542 valve, I'm most interested in their intake manifolds, which I think are really, really cool. In fact, the 542 valve, the aluminum one, is what I use to make my adjustable manifold for the 462 valve stuff. So we took their super long cross rammy kind of thing, super long runner truckish kind of manifold, which is typical. And then we just cut the manifold off. And so we just had flanges that have everything we needed. It had the flanges, it had the injector holes, it had the mounts for the rails, it had an opening for us to weld any kind of tube on it that we wanted. We welded tubes, actually just standoffs, and with flares. And then I could slip fit any length of tubing, and then I had other lengths of slip fit tubing, and I could stack them. And we had plenums for each side. We had a joiner to connect the plenums, and voila, it was awesome. And then so we had adjustable intake manifold. I just saw tonight that the podcast is out. I'm going to watch it. Yeah, go check it out. How's our poll doing? 67% are no. It should be like 100% yes. So everybody that says no, you need to go watch that. I mean, he did a really good job on the for a guy not being like an LS guy, which is what the podcast was about. Like I could have talked about anything. We could have talked about Hondas or whatever, but for not being an LS guy, I thought he did a great job. The G35 for my LS1, it's an 2002 Trans Am. Truck plus cam on E85. Years of 373. Hope to be around 800 horsepower to the wheel, or at least outrun a Dodge Demon. I'll report. Yeah, let me know. 800 at the tire is going to be a lot. We did have somebody make 735 at the tire on the GTX turbo. So I think that that's possible. I think that will be at the end of it. Honestly, if I was trying to make that much at the tire, I would have a G42. Can't go wrong with the K series. I know it's not, and it's a K24, so it's like the big block of K series. TPI runs good so far. It's my Firebird stock ECU. I would say it runs a little rich. It also has a small injector upgrade. Well, the thing that will happen with modern engines like that are running an O2 sensor and are running in closed loop, that as long as you give it, as long as whatever the factory parameters were, if they gave it enough room, that under cruise, it will run around at the desired air-fuel ratio, because it'll do short-term fuel trims, which will become long-term fuel trims. It will do those cruising around. My concern is more at wide open throttle. What's going to happen at wide open throttle? Because you have things that have added a lot of power at whatever engine speed. I don't know if yours is, I don't know if an 89 is a mass air meter or not. If it's a mass air meter, it could be somewhat, self-compensating at wide open throttle, but it's not going to be what it could be with a tune. I feel like it's not optional, and of course it's not without a tune, but just curious what my gains would be. I don't know, because we have no idea to know where you are with no tune. It also has a small injector upgrade, 2 more than stock. I'm surprised that the thing will go wide open throttle with the modifications that you've made with stock injectors. Because stock injectors, I think, on a tune port motor are pretty small. And you have increased the power output by a lot. Plenty more parts for a K series stuff out there. That would be wild. Yeah, just forget about what you would do. If you just put a turbo on a K series, it's like a lot. Have you ever run a 6.2 4-valve out of a Raptor? I have not. I don't know that I've ever even seen one other than maybe online. Picked a couple of LV3s, which I think would be wild. The turbo in a Chevette or Vega. They would be. That is awesome. Something really light. Brian Tooley did some testing with those. They didn't have good luck with them, but I don't know if that was a problem that they had. I don't think it's something inherent in the motor. But they make a lot of power just stock. And then they did a bunch of stuff. I don't know if they ever got to porting the heads, which is just a LT head, basically. I feel like with some cams, it could do pretty good in a light car. Guy has one, a Crown Vic that he stick shifts. No, that's it. A 6.2 is a good motor. A 4-valve motor has really good, like that kind of head design, has really good flow. So if you can put cams in it and stuff, it should make good power. It's like a big Coyote. Wasn't aware of Street Alpha, but I'll have to check it out. Yeah, I should go check it out. It's good. I have a Chevette. I thought about doing the LV3 myself, either that or a 3800. Yeah, Chevettes are cool. Chevette front-wheel drive or rear-wheel drive? It's rear-wheel drive. Is it true that BTR got bought out? They did. Ecotech Supercharged for an Omni would be different. Yeah, I don't feel like that would be enough of an upgrade, though. Like a turbo K24 is going to be 600 horsepower. Would a TPI system offer any advantages over a TBI in a towing situation? Yes, it would. I think it would offer way more torque. Ecotech has a 4-cylinder record. They have a Bonneville record that I'm familiar with. Ferrari had an intake with adjustable intake stacks based on RPM. Rev it up, and they'll get shorter. The BMW one looked really slick too. Yeah, I remember the BMW one was actually a rotating scroll, and that sort of stuff is not uncommon. Chevette is rear-wheel drive. Yeah, that's it. BTR did get bought out. I'm an import guy, and I'm getting into LS more recently, but I've always been curious what's the difference between a big block and a small block. Because displacement isn't always bigger. No, they had 396 big blocks and they had 400 small blocks. So it's about an engine family thing. It's a bore center basically and the size of the motor. Camaro 3800 and the Chevette should be interesting. I thought it would have run worse, but I'm glad it also runs because I like driving it. Stock injectors are 22, so I have 24s. Looking at FITech self-learning system maybe. Time for some pizza. There you go. We had pizza last night. Friday night was pizza night. My next turbo Buick guy. There are some turbo Buicks with LV3s and a turbo now. I know BTR said they broke rods at 7,000 RPM. Scoggin Dickey does a piston rod upgrade. Yeah, I think that they had oiling issues that BTR did. But yeah, no, those motors, I mean, because it's a small, it's a 3/4 of an LT1 kind of thing. I think it's 3/4 of not an LT1 of something else, but it's basically 3/4 of that size motor of a 350. It's got to be one of the supercharged 3800 stock blocks, some springs, and a small turbo. You got 600. Superfoot. What thing are you talking about? Scrolling. It's got to be one of the supercharged 3800 stock blocks, some springs, and a small turbo, and you got 600. Yeah, we made 612, I think, with not too much work. Do you reuse hydraulic lifters when swapping out cams? I do all the time. The L33 that I have that we have 700 dyno pulls on and 200,000 miles on still has the original lifters in it. It has 100 pulls at 7,800 RPM. So yeah, we reuse the stock hydraulic roller lifters. I don't reuse stock hydraulic flat tappet lifters normally, but honestly, I think you can. I think that this thing that they're somehow matched to the cam is not a real thing. I do think Jobu needs a refill. Makes me feel better. I just swapped cams and lifters. Look so good. I just put them back in. Yeah, on an LS, we don't even look at the lifters. We spin the cam around. If the lifters hold up in the trays, we figure the lifters are fine. And now we think that the trays are fine because the lifters haven't dropped back down. Then we swap the cam and we reuse those lifters. One of the problems you have is that with real high mileage stuff is the lifter trays on the LS will wear out. And when they do, it can allow the lifter to rotate around. And this can happen with one of the things I was watching on social media. Somebody brought this to my attention is that I think it might have been Billy Godbold, that on, I don't remember what the lift value was, but on very high lift stuff that there's a limit to how much lift that the tray will accept relative to the position of the lifter. And then it can jam up in it and want it to rotate and stuff and cause problems. Flat tappet lifters always make me nervous. Breaking in, once they're broken in, I'm relaxed. Yeah, I did fingers crossies when I did all of those muscle car motors that had either hydraulic flat tappet cams from the factory or solid flat tappet cams. Honestly, I was less worried about the solid flat tappet stuff back then. But yeah, we were worried until they were broken in, and once they were running and we're like, and we're making pulls, we're like, it's fine. Is there a general rule for boost limit when running 93 pump gas on street with 9.4 to 1? No, there's not. It's all in whatever the tune is. The tune is a critical thing. What you want it to do is not detonate. That's very, very important. Do not detonate. Yeah, some engines are much more susceptible to detonation than others. An iron-headed motor, not great. Aluminum-headed motor, better. Some aluminum-headed motors, even better. Depends on water temperature, air temperature, all that stuff. Because the problem is when you tell somebody, yeah, you can run 10 pounds boost on 94 octane or 93 octane. Well, you can and you can't. You can when the timing and air fuel is right and the air temperature is right and the water temperature is right. But if you miss just on one of those things, you can't do it anymore. And then, you know, it's not as bad now that modern engines are more forgiving if you have the knock sensors hooked up. If that's working, and then it will pull timing because you've made a what would otherwise be a critical error, because you've made that and it's did its little nanny features and saved you. That's good. That's a really good thing. But if you don't have that, like small block Chevy, small block Fords, or whatever stuff back in the day, good chambers require less timing and are less prone to detonation. Yeah. Good chamber designs, and then good chamber material. And then if they're softened, I saw an interview with Alex, somebody saying some of the modern Porsche engines run boost at lambda. Seems crazy to me. I don't know. Dan, do you know anything about that? Or any of the Porsche turbo stuff running 14.7-1? Are they doing it at a reduced timing amount or something? I remember the VW guys talking about that. One of the German engineers that came with us when I did I think that this was on, if I remember right, I think it was on when we did the hybrid Jetta one. And he was, you know, he was a Volkswagen engineer, so he knew everything in the world more than, you know, he'd never been to Bonneville, never run race gas, didn't know any of that, but knew everything. And so, but he was telling us, I'm like, we need to run this thing at 11.8 or 11.7 or 11.5. Why? We run it at 14.7. I said, you run it at 14.7 at 20 pounds of boost, sustained for a minute and a half. Yeah. Like, that sounds like a horrible idea to me. So, but maybe they can. I don't know. It would have been a learning experience for me. Richard, I saw a post about Straub, LS, and LT head gaskets with the extra coolant passages. They claim 18 horsepower and 20 degrees cooler. Just wondering if you have any input. I saw that too, but I don't know how they're doing that. What I would want to see is I would want to see the change in running temperature under the same conditions. 20 degrees cooler, I have never seen 18 horsepower. Because I've done temperature changes where we've changed the water temperature by 20 degrees and it's not 18 horsepower. So those two things don't go together for me. But what I would want to see is if they are changing the combustion temperature, maybe there's something there. I'm interested in it. I just, you know, somebody says a head gasket that's 20 horsepower or 18 horsepower. I'd like to see that because I'd also like to see how the OEM engineers missed by that much. 14.7 under boost, but it's a DI engine. Oh, okay, yeah, a DI engine would be different. That none of these were that. These were all port injected motors. Must be high on high octane fuels or E85 with that type of air fuel. None of the factory ones have water injection. Did Steve Morse run NA timing under boost with you on the LS? Yes, he did. We cover all of the timing numbers in the videos that we ran, and it was ridiculous. DI engines don't have to worry about as much about detonation. Yeah, because they don't have the fuel in there until the last moment. Regarding the Steve Morse thing, I think what was going on is the way that he does his testing, he runs at such a very, very high acceleration rate on the dyno that makes it much less prone to detonation. We could not run the timing that he ran on the supercharged motor when we run it at WestTech. It would definitely hurt it because we're running at 300 RPM per second. I think when he was running at least double that because I don't know exactly what the number was, but it was very, very fast. Is there performance to be gained from doing pre-throttle body on a turbo setup? Pre-throttle body what? Pre-throttle body water injection? Is that the question? I mean, I don't see your question correlating with somebody else's. What are the advantages of valve angle? There are lots of advantages to valve angle. One of them is improved flow. The other one is improved piston to valve clearance. Usually shallower valve angles help improve airflow. That's why all of the really good, like small block Chevy heads, all of the LS heads are like 11 degrees. A small block Chevy head's 23 degrees or 24 on the big block side. So, but a big block Chevy is a canted valve too, so it also has side counts. So there's other things going on there. But none of the more racier big block heads or small block Chevy heads, none of them are 23 or 24 degrees. They're all 20 or 18 or now even less. I mean, they're 10 or 11. You mean putting a throttle body in front of the turbo? That has been done, and I'm told, I have not tested this, and nobody that I know does this in any form of, like, the guys that are making lots of power or whatever. They might do this on road racing or something, but it's supposed to help keep the turbo spooled up. But I think that the blow-off valve kind of does that too. I'd like to see a trace of impeller speed of having a system set up like the way that we normally do with the throttle body, with the thing blowing into the throttle body with a blow-off valve, and then with the throttle body mounted in front of the turbo. I'd like to see what the change is in impeller speed, like during shifts and stuff. I'd be curious to see that. I rewatched the whole 2.5 hours. Is that what, Scottish, was that what the podcast was 2.5 hours? I watched it too. I was fascinated by it. Big drawbacks of that is the turbo will have manifold vacuum and will try to suck the oil through the seals in the turbo. You need special oil seals in the turbo. I think that that's probably a similar problem for carbureted stuff, for draw-through setups. I mean, we know we have carbon seals in there because of the fuel, but also on D-cell, you would still have vacuum there. Would a modern turbo like vacuum at the compressor? That's what I was just talking about, Dan. I don't think it will. I think we have millennial turbos. I think that they're not gonna. I don't think they're gonna put up with that. I picked up an LS1 intake for my Turbo 5.3 build. Is there a boost limit where I should be concerned about plastic manifold holding up? You won't make enough boost, and you're not going to do it with a GTX 3584. You're not going to make enough boost on an LS1 intake manifold to have to worry about that. And you're not going to make 20 pounds on that turbo with on a 5.3. You just won't get there. Not on a cammed 5.3. You don't have enough turbo to get to 20 pounds. What are you doing here? Did a draw through on an air-cooled VW, ran great. Yeah, I've seen those. I've seen a lot of those actually. Picked up an LS1. Okay, there we got that. Any opinion on using port injection with a separate fuel cell for auxiliary fuel addition to the stock DI? To recommend E85 or water methanol mix in an auxiliary tank. What motor are you talking about? And why are you trying to use a different fuel for the port injection as opposed to the DI injection? That'd be my question. So I used to do big YouTube interviews about fish tanks and aquariums. I was huge into that stuff. Cool. So why did you stop doing that? If you were big in the fish tank world, I think it passed a lot of oil. That's kind of what I would be worried about. Thetis is giving away turbos. I know that he's he's a millionaire. He can do that. I need to replace my 7875. My best friend used to be in aquariums. His name was Scott. Do you know him? Do you know Scott? So we're going to close out our poll at 63% saying no. Shame on you. Go watch that. The Street Alpha podcast. It's really good. There's a lot of good information there. When you blueprint a small block Chevy, what are some of the measurements you absolutely refuse to compromise on? I've never gone through and blueprinted a small block Chevy. But if you, I think some of the important things would be getting the piston to zero deck. That would be important. Sometimes they square and parallel this stuff and line hone it and bore it and do all these things. And all of that is like ultra critical to them. To me, it's not, because I think you get to a point where some of the big things add power or longevity or whatever, like getting the things all to zero deck. But if you have one where one piston is at 5 down in the hole and the rest of them are at 2 down in the hole, and let's say you get them to zero deck and one of them is 3 down in the hole or whatever the number is, how do you get that one to be equivalent to the others? I don't think it's necessary. Like, I don't think that you can do that. So getting them at zero deck would be a big thing. I don't know. And I don't care about getting like ring gap exactly the same. I don't think that does anything. I think if you have one cylinder where the ring gap is 26 thousandths and the other one's 27 or 28, I don't think there's any dyno or system alive that could measure that difference. I just don't think there is. Maybe there is, but I've never seen it. Tight quench keeps detonation in check, at least on small blocks. Car has a Mazda speed 2.3 with a Borg Warner S257. It needs additional fueling as stock injectors don't have upgradable injectors. Port injection helps keep intake valves clean. That's absolutely true. But why? But my question is not that you're adding port injection. That's a fairly normal thing. People do that on the DI LT motors. The Coyote kind of already does that because they have both of those systems. But my question is, why do you run different fuel on the fuel augmentation for the port injection compared to what you're running in the DI? Why are those fuels different? You have to rebush the rods. Interesting. What size turbo for a 2.3 liter 4-cylinder for 25 pounds? That's not the question. The boost has nothing to do with it. Your question should be, my question to you is, and your first question should always be when you're talking about a turbo is, how much power do you want to make? So how much power does your 2.3 liter make NA? And then how much power do you want to make? The turbo is going to dictate how much power you can make. You want to make 200, 300, 400, 500, whatever that is. You don't want to make a boost level. You want to make a horsepower level. And then we figure out how to get you there. Won't compromise on piston to valve clearance. Yeah, that's pretty important. Valve guide clearance has to be 2000 no matter what. And bearing clearances, all those are normal things, but none of those things I don't think go into, at least I don't think that they go into what's called blueprinting a motor. Blueprinting a motor, for me, the way it's been described to me, because I've never done it. I've never gone to that level. I don't think it's necessary. But would be making everything exactly perfect. And there are guys that want to do that. They want everything that they do. All the bolts have to be exactly so. All the things have to be chased. Everything has to be exactly right. That's not the way I want to build a motor. Because I think like with everything else, that at some point it doesn't add anything to the equation. All it does is take away time. And so I don't do that. Fuel switch in the middle of operation ration, you lose. In your humble opinion, what's the biggest small block Chevy, big block Chevy myth that refuses to die? I don't know about small block Chevy stuff or big block Chevy stuff. I'm trying to think of a common one. you think a cheap turbo kit under $1,000 is okay for a tune port if I want 500 wheel horsepower or maybe 450? Yeah, I think turbo is definitely the way to go. But you got to be able to tune it, right? Mr. Dino wants a good camshaft for a 350 small block. The motor's already bore 60 over. I want to make 400 horsepower. Okay, but I need to know what the rest of your stuff is. Because if you have stock heads on it, 400 horsepower is not going to happen. Does it have good heads on it? Does it have an intake manifold? What am I working with? A 400 horsepower small block is going to be a 224 to 228 at 50 camshaft. Steel Star Auto, was yours the 2.3 liter? And you want to make 500 to 600 horsepower? Okay, have you done anything else to the motor? Is the motor all stock? Because it's going to take a lot of boost to get you there. It might take 25 pounds, like you were saying. But 500 horsepower, probably a 3076, maybe a GT 3076. Oh, 200 for a 5.3. So 500, geez, better fuel for octane, cooling, shooting for 500 plus. GT35 size turbo probably get you there. Yeah, I think even a 30 would get him there. Myth that never dies. The 396 is the old man's car. Couldn't grab a $100 bill on the dash. Yeah, that's jumping Coke cans and all that stuff. Yeah, I just was trying to think of a good one for the big block Chevys. Because I remember driving those cars. Not that I ever had them, but I remember driving people that have, usually parents of the girls I dated and stuff. But they were, and they felt impressive, especially compared to my little 4-barrel Camaro. But like I've ridden in like turbo Fox bodies and even turbo CRXs and stuff. I'm like, that car would just get killed by this car. Yeah, GT 3076 or a 3582 that would certainly make that kind of power. And there are probably like Garrett versions and BorgWarner versions that I'm not familiar with. I don't have the numbers for, but they'd be really expensive, and I don't think you need that. The other thing I want to mention at richardoldnerperformance.com, we don't just have a G42 1200, we have a G42 like 1400 or 1450 or something. So if you want something bigger than the 1200, we also have that. Today we're making serious power and we can easily reach the dash. Yeah, that's right. Would a GT45 T4 turbo be okay for a 500 horsepower tune port motor, or would you recommend that you have? First of all, I need to tune it, but I'm ready to get more power already. That turbo will make that power output. It's a little probably softer, and honestly, our 3584 would be better than that turbo, and to be more responsive. Because on a tune port motor, you have about 5,000 RPM worth of working useful RPM. And it'd be way better for you to have the turbo come on much more responsively than a GT45 does. I mean, it will work, and you can get them for, I don't know, $200 or $300. I don't know what they are now. But our 3584 is just way better. If our 205 heads, Holly carburetor, double pumper, stock crankshaft, BorgWarner S257 SEX. Okay. Bobby, what was your thing here? Oh, a 350 small block. Okay. I want 400 horsepower. Here we go. Oh, you have those heads? Yeah. 224 cam is going to be fine. Holly carburetor, 750 double pumper. That's good. Stock crankshaft. I'm assuming you have an RPM error gap or some kind of intake manifold. Yeah, 224, 232 kind of cam. 224, 230 that is going to get you to 400. M11 Mercedes-Benz motor, forged rods and pistons. Okay, those are good. M111. Big Shark. We got one more minute because I'm Joe Boo and he does need to refill. So nobody got my, that's really esoteric. So the answer to my, makes me feel trapped inside And this is a movie probably nobody has seen. I think it's called Pele. So it's about Pele, the soccer player. And it's one of the little kids that said it. It's freaking awesome. But I'm a big fan of Pele. Any idea if you guys will bring any bigger cams to the website? I ordered the Truck Plus. I'm about to click the button on a low buck truck. Love the prices. Just wonder if any bigger's in the mix. Jimmy and I have talked about that, and we are thinking about that. Oh, the thing that stops me from doing that is I already know what profiles I want, but I don't know if we want to go to the 224-ish, 227 range or to the 231, 235 range. I don't know that we do both of them. We're not a big company. We're a little company. We're not Garrett. With your big turbo engines and bigger cams are finding a limit with L7 lifters or valve springs. We don't, none of the things that I've run, including the 1500 horsepower stuff, have been, I don't run bigger cams in them. We run cams that are in the 220s on all these turbo motors, maybe 230, but we've never had any problems with L7 lifters. My glass is empty. I need a refill. There you go. I'll speak for everyone. We will support you in any way we can. That's great. Yeah, I would like to do the cam that I would like to bring back to market would be something similar to that crane cam that I've tested a whole bunch. Be happy with a cheater cam, a stock idle. The Ripper cam sounds a little cammy to me. The Ripper cam is not cammy. Is that what you have? A Ripper cam should have a really good idle. But I would almost like to do a smaller cam for 408s. I mean, for 4.8s, not for 408s, for 4.8s as well. Because there are guys that just want, hey, I'm okay with adding 30 or 35 horsepower or whatever, but I don't want to lose any power down low. Because on a 4.8, as we go from a 6.0 to a 5.3 to a 4.8, the cam gets bigger. And so our trade-off area becomes more pronounced on the smaller motor. So a smaller cam for a 4.8 is a better way to go. I'll say without a tune, my idle is definitely not good. Having to idle at 900 to get it not to surge. I'd like to see you test turbo inlet piping sizes. Most turbos these days run 4-inch compressor inlets, but sometimes space dictates small filters or smaller diameter piping. So you're restricting the inlet going into the turbo? We don't ever do that. You don't want to restrict the inlet going into the turbo, and you don't want to restrict the size of the exhaust exiting the turbo. Both of those are important. But only if you're trying to max out the turbo. If you're running 10 pounds, none of those things will hurt it. I've only heard idle clips on YouTube. Not sure if the mic attenuated it. Yeah, a Ripper cam and a 5.3 or a 6.0 shouldn't have a too cammy of an idle. It's definitely going to be less chop than a low buck truck or a Truck Plus. But it's not going to be a stock idle, that's for sure. You won't get, it's hard to get stock idle and then lots of power gain. There are some with wide LSAs, but the problem with those is they only gain power at the top of the RPM range. My perfect engine would have a choppy cam and turbo noises, just all the goodness. Turbo-y goodness, choppy goodness. Inlet restrictions push turbine pressure. How does an inlet restriction push turbine pressure higher? Curious, there's still lots of pre-3800 over in wrecking yards in the USA. The Portman's 109 Buick. Are you talking about V6s that are not the 3800 Series 2 motor or Series 3? Talking about 3.8 liter stuff? Because there's a lot of 3800s, but I don't see a lot of, like, there's no Grand National motors there, if that's what you're asking about. And on that note, it is time to go. You guys have a good night. I think it's Saturday night, right? So you guys should have a good Saturday night. It's the weekend. Go party. Also, I forgot to mention, since everybody's here, Jimmy got the S2000, the head that some of you guys saw, that the head that was ported that he put on there. He didn't do the porting. The head came that way. Put it on his S2000 with a turbo and everything on it, but the head was leaking water. So they ported through to water. Not cool. He has another head, stock head, that they got, put it on, engines running, things running. So he's going to be driving around, I think, tomorrow, and then maybe we'll see some dyno testing. It would be really cool. So I'm excited. Thumbs up to Jimmy for getting that done. That's awesome. Getting projects done, and then allowing us, hopefully we'll be doing a bunch of testing on different turbos. So it'd be very, very cool. So awesome news on the S2000. It's up and running, and it's chock full of turbo-y goodness.